Welcome. What we're going to do today is take some time and go over every single question on the assignment Overall Gravity Review. I will go over every question in order, in addition to some of the general concepts that we have learned about gravity, free fall, and the word problems. I would encourage you to watch this fully. I would encourage you to try the problems on your own first, and as a means to either check your work or answer your questions, then watch the videos through the question where you are. If you are totally lost, you could also just watch this in its completion and hopefully find an answer. So, here are some of the basics about gravity, and I want to be very clear that we're going to go over some of the concepts first. Here are the first 6 questions on the assignment. And I want to make sure that everyone is on the same page about what these things are. When I says the first question is, what is gravity? Just general, what is gravity? Gravity is an acceleration. Okay? That's what gravity is. Gravity is an acceleration that speeds things up as they fall to the ground. As an object falls to the ground, it gets faster because gravity accelerates it to the ground. And if you don't remember acceleration, that means speed up. In this case, objects speed up as they fall to the ground. What is the value of gravity on planet Earth? Well, the value that I said we would use for this class would be -10 meters per second squared. Why is it negative? Because it's going down. Down is a negative direction. 10 is simply the value of gravity, and meters per second squared is the unit for gravity. If a golf ball and heavy book were dropped at the same height at the same time, which one would hit the ground first? Well, gravity pulls on all objects with the same acceleration. So in this instance, these two objects would hit at the same time. Remember the videos we saw. Remember the experiments I told you to do, that if you dropped 2 objects the same height at the same time, they will hit the ground at the exact same time. Gravity accelerates them equally. However, if I look at something like number 4, and if I say a piece of paper and a bowling ball were dropped from the same height at the same time, including air resistance. When I say including air resistance, that means there's another force at play here, the air. And we know that the air is going to slow down the piece of paper. So that means gravity is not the only thing acting on the paper. Air resistance is also acting on the paper, which means the bowling ball would hit first. When you include air resistance, things like a feather, things like paper, light, small objects will get slowed down by air resistance. However, if I look at number 5, where if the exact 2 objects, a piece of paper and a bowling ball, were dropped from the same height at the same time, ignoring air resistance. So that means no air resistance. Another way of thinking about that would be in a vacuum. And if you remember that word, that means no air resistance. In a vacuum, no air resistance. Just like the video we saw of the bowling ball and the feathers, now they would hit at the same time. If you ignore air resistance, all objects hit at the same time. And what has more gravity, the moon or the Earth? Well, more massive objects have more gravity. Smaller objects orbit larger objects. The moon orbits the Earth, not the other way around. That means the Earth must have more gravity. The Earth orbits the Sun. That means the Sun must have more gravity. More massive objects have more gravity. A free fall is simply when an object is dropped and only gravity acts on it. There is no air resistance in a free fall. All objects experience a free fall in the exact same way. So regardless of what object we're talking about, when we talk about free fall, we don't include air resistance. So we're not talking about how the air causes a feather to float to the ground. That's not a free fall. That's something else that we haven't learned yet. Free fall does not use air resistance. Free fall assumes things are in a vacuum. Okay. The charts. These charts can be tricky. So I want to go through a couple of charts together. Fill in the following free fall chart for planet Earth. Okay, what is free fall? Free fall is simply dropping an object and only letting gravity accelerate it. So, I've said that please remember, whenever you do a free fall, the velocity and the distance start at 0. Always, always, always. You don't even need to know what the gravity is. You don't need to know the time. You know that at 0 seconds, the velocity is 0 and the distance is 0. Because at 0 seconds means it's not moving yet. So everything starts at zeros. Because I say this is on planet Earth, we know the gravity on planet Earth. We know that gravity is an acceleration. It is going to experience an acceleration of -10 meters per second squared. There are a couple ways you can think about this chart. You could go ahead and use the V equals AT equation to solve for the velocity at every single second. The A will always be -10. That never changes. And you can keep plugging in the different times. Or you could recognize that acceleration is how much the velocity changes every second. So if we start off at 0, and we will always start off on 0 in a free fall, after 1 second it's going -10. After 2 seconds it's going -20 meters per second. These aren't milliseconds, by the way, it's meters per second. -30 meters per second, -40 meters per second, and -50 meters per second. You can check your work using this equation if you'd like, but understand that it just changes by this much every second. You just keep minusing 10 every single time, or whatever the gravity happens to be. How then do we get the distance? Well, we're going to get the distance using this equation. D equals 1/2 AT squared. Specifically, we know we're looking for the distance, and every single time we're going to use the same acceleration, the acceleration from gravity. -10, and this is going to be constant every time we use the equation. When we did the problems before, I said you could literally copy and paste this from problem to problem. But something changes every time, and that's going to be the time. The time is going to be different. So let's solve for the distance at 1 second. So I'm going to put 1 squared here, okay? So what does that equal? That's going to equal distance equals half of -10 is -5. That's all I did. I just took half of -10. I got -5. 1 squared is 1. The distance equals -5 meters. -5 meters. Okay. So I got the distance at 1 second. I used gravity and the time in this equation. So when I do it for 2 seconds, I'm going to use the gravity and the time here. So I want to let you guys know, please, 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 this is not acceleration. These numbers never go in the equation. These are velocities. Don't put these numbers in the equation. What you're going to do is you are literally going to use the exact same equation that we just had. The d equals 1/2 -10. And I said the only thing that changes is the time. 2 squared. Okay, so what does this look like? D equals 1/2 of -10 is -5. 2 squared is 4. D equals -20. Okay. All I'm trying to show you is that you're using the same equation, this equation. You're using it again and again and again. But every time you use it, you're leaving the acceleration the same. The only thing that you change is the time. So I know the setup for the other 3 seconds are going to be d equals 1/2 -10. And if you get used to, oh, can I just call that -5? You can. 3 squared. D equals 1/2 of 10, is -5, as I just said. -5, 3 squared is 9. -5 times 9 is -45. This is how you get the distance every single time. The gravity stays the same, and you just change the time in the equation. Gravity stays the same, and you change the time in the equation. Don't forget to change the time. Some people just copied and pasted everything, and it left it exactly the same. You do need to change the time every second. How did I know it was 3? Because I was solving it for 3 seconds. Oh, okay, that's not too bad. Well, what about 4 seconds? What are we going to do now? Well, I'm going to use the exact same equation. D equals 1/2 -10. The only difference is the time. 4 squared. D equals -5 times 16. D equals -5 times 16 is -80. Look for patterns. Look for patterns. If you see patterns, that's great. If not, solving this equation out like this every single time will work always. But I want you to really see what is the same with this equation. 1/2 of -10, 1/2 of -10, 1/2 of -10, 1/2 of -10, because -10 is the gravity. That's why it's staying the same. So the last, almost out of space, but I'll do it right here real quick. D equals 1/2 -10, 5 squared. D equals 1/2 of -10 is -5. 5 squared is 25. Multiply those numbers out. 125 negative. This is how you fill in a free fall chart. It is important that you understand how this works so that you can do it if you have a different gravity. Understand what changes and what doesn't. Because now I've switched it up. Now I'm saying fill in the following free fall chart for a planet that has a gravity of -3 meters per second squared. So it's the exact same process. We're still going to use this if you want. We're still going to use this. But the only difference is that instead of the A being -10 every single time like it was on Earth, now it's going to be -3. The A is -3 meters per second squared every single time. Okay. So let's remember some things. I want to warn you guys because a lot of people have been making this mistake. Do not start out like this. This is a common mistake that people have made. Don't do that. You don't start with the gravity. you start with 0. Okay, I need you to see this. You do not start with the gravity. You start with 0. Okay, it's going to be 0, then -3, then -6. So you had the right pattern, but you just, by not starting with 0, your numbers got to be a bit off. So I want you to be mindful of that. Do not start with the gravity. Start with 0. You always start with 0. So how do I gain these numbers? I'm just going by -3 every single time. -3 every single time. -3 every single time. That's it. You can check your work. The A is -3. -3 times 4 is -12. It works like that. -3 times 5 is -15. You can check your work. Make sure it works out. If they don't equal, something has gone wrong. So, okay. We always start with 0. Double 0. Don't put the first distance here. Always start with 0. So now I need to get the distance at 1 second. All right, how's this going to work? D equals 1/2 -3 1 squared. All right, let's figure out where this came from. The A is -3. The time is 1. So when I do this equation again and again and again, the only thing that's going to change now is the time, just like before. I'm going to leave everything else the same. Half of -3 is -1.5. And when I do a half, half is just divided by 2. So I could do -3 divided by 2. 1 squared is 1. The distance, -1.5 times 1 is -1.5. That's it. Okay, well, let's go see. Let's go see. So when I do it for 2 seconds now, what's it going to look like? All right, we're using the same equation. D equals 1/2 A. What's A? Oh, -3. Not -6, not the velocity. It's always going to be -3. And now the time is 2 squared. So, okay, let's solve it out. D equals half of -3 is -1.5. That's always going to be true. Once you know what half of the gravity is, it's always going to be true. 2 squared is 4. D equals -6. Oh, nice. This isn't so bad. No, it's not. It's really not. Okay, what about 3 seconds? D equals 1/2 -3. That's always the same because that's gravity. But now we're going to use the time of 3 seconds. Awesome. D equals -1.5 times 9. D equals 13.5 meters. Negative. Just type in -1.5 times 9. Simple. Once you know the pattern, it never changes. D equals 1/2 -3. But now we're going to do 4 squared. Nice. Half of -3 is -1.5. 4 squared is 16. -1.5 times 16 is -24. And then lastly, D equals 1/2 -3. Okay, now we always do that. Now I can go look. Oh, we're going to use 5. 5 squared. Half of -3 is -1.5. That's always going to be true. Times 24. 5. And then negative 1.5 squared is 25. And what negative 1.5 times 25 is, of course, negative 37.5. That's it. That's how you can do any freefall chart correctly. It always works the same way. So now we're hitting the word problems. And this is where we really struggled. So if we're going to have word problems talking about falling or dropped, and an object is falling, what causes something to fall? Gravity. So if something is falling and we're on Earth, we can assume that the gravity is negative 10. Okay? That's what we're saying up here. On Earth, we know that if something is falling, it's falling because of gravity. So that means the acceleration is negative 10. And now, because there's an acceleration, there's only two equations. There's two equations that we can use for the word problems. We can use v equals at, and we can use d equals 1/2 at squared. These are the two equations. So how am I supposed to know when to use which? When a question says how fast, that means you're looking for velocity. That means the equation you will always use is v equals at. When a question says how far, it means you're looking for distance. So the equation you will use will always be d equals 1/2 at squared. When it gets tricky is when a question asks for how long. If a question asks for how long, it means you're looking for time. So now you have to pick v equals at or d equals 1/2 at squared. And we'll get into in just a second how you pick which one. Okay, a ball is dropped on planet Earth. Okay, so when I see dropped planet Earth, okay, this is pretty obvious that the A is going to be negative 10 meters per second squared. This is the next set of questions on your assignment. And I want to be very clear. I have a group of questions just to practice how to solve for how fast. When it says how fast, that means you're looking for velocity every single time. And I said that when you're looking for velocity, there's one and only one equation you're going to use. Velocity equals acceleration times time. The acceleration will always be gravity on planet Earth, which is negative 10. The only thing that's going to change every single problem when it says how fast is the time. That's it. That's the only thing that changes. Let's see how it works. So, we're looking for how fast. We always know that the A is negative 10. And in this first question, we have a t of 8. How's this going to work? Well, I have my list of variables, v, t, a. V equals at is the equation. V equals negative 10 times 8. We'll multiply those together. Negative 10 times 8 is negative 80 meters per second. That's it. That's it. Every time. How fast? V equals question mark. The time, now it's 9.2. I love decimals. Don't be scared about decimals. That's okay. It works the same way. It's going to work the same way. V equals AT. V equals negative 10 times 9.2. V equals negative 92 meters per second. Yes. Yes. How fast is it going after 14.5 seconds? Just like with the free fall equations, the only thing we're changing here is the time. Velocity equals acceleration times time. because it's dropped. We know that the acceleration is negative 10, and we know the time is 14.5. Velocity equals negative 145 meters per second. That's it. That's it. What about 20 seconds? Okay, no different. V equals AT. V equals negative 10 times 20. V equals negative 200 meters per second. Because they say how fast, so every time you see how fast, V equals question mark and V equals AT. That's it. That's all we're doing here. So 31.7 seconds, V equals negative 10 times 31.7. The velocity equals negative 317 meters per second. Just multiply the numbers straight across. So these problems, because it says planet Earth, it expects you to know that the A is negative 10. And once you know that, it's pretty easy. It's just negative 10 times the time. Now, exact same questions, but there's only one difference. Instead of how fast, it's now saying how far. And when it says how far, that means you're looking for a distance every single time. D equals question mark. But if it's dropped on planet Earth, okay? If it's dropped on planet Earth, that means we always know the acceleration. The acceleration is always going to be negative 10. The acceleration is always going to be gravity on planet Earth. Every single time. And these are the times, and these are the times. So they give you the times. So you have D, A, and T. You have them. So that means, and I told you before, that if a question says how far, this is the equation that you use. D equals 1/2 AT squared. So all you're going to do is plug in D equals 1/2 negative 10 8 squared. Hopefully you're getting good at putting this in your calculator. If not, you can still break it up into steps. Half of negative 10 is negative 5. 8 squared is 64. All right. Negative 5 times 64 is, of course, negative 320. And that's how far it goes in 8 seconds. That's the first one. Don't forget to write these down. All right, 9.2 seconds. Oh no, Bizzuto, really? Decimals? It's okay. You have a calculator. It's okay. 9.2 squared doesn't mean 9.2 times 2. It means 9.2 times itself. 9.2 squared is 84.64, in case you want to check your work. Half of negative 10 is negative 5. So when I multiply 84.64 times negative 5, I do get an answer of negative 423.2 meters. That's it. Okay. Well, what about the next one? The only thing that changes is the time. D equals 1/2 negative 10 14.5 squared. I could just put that in my calculator. 0.5 times negative 10 times 14.5 squared. I just hit that and I just get the answer of D equals negative 1051.25. Make sure that your calculator can say these numbers. If you can't make your calculator get these numbers, ask for help. I will help you. D equals 1/2 negative 10 1t squared. In case you can't see where these numbers are coming from, I'm just going through the questions. That's all I'm doing. That's all I'm doing. D equals, and then the answer is here, 0.5 times negative 10 times 20 squared. Yes, negative 2,000. And then lastly, 31.7 squared. Doesn't matter what the number is. Doesn't matter. Everything else stays the same. Everything else stays the same. 0.5 times negative 10 times 31.7 squared. Yeah, you get crazy huge numbers, you get decimals, but it doesn't matter. You know what you're doing, and you have a calculator. These are the answers for these 5 questions. You got this. So that's how far. Now, this is where it got a little tricky. When it says how long. Because I said how long can be either v equals at as an equation, or it could be d equals 1/2 at squared. How long, how long, how long? So how do I figure this out? Okay, dropped on planet Earth. When you see that, a negative 10. Gravity, we know that. We just got to know that. All right, so it says how long, so t equals question mark, a is negative 10, okay? And then it says how long does it take for it to end up moving? Negative 13 m/s. Okay, this is important. Negative 13 m/s. Because it's m/s, I know that that is a velocity. I have to know that the unit for velocity is m/s. So because I have a velocity right here, because I have a velocity, that means I'm using the velocity equation. I don't have a distance, so I'm not using the distance equation. That's how you know. When you read the question, it says how long, you know you're looking for time. You have to see, are you given a velocity or are you giving a distance? If you're given a velocity, you're going to use the velocity equation. If you were given a distance, you would use the distance equation. So let's see how this works. Okay? But don't forget, these are actual questions on your assignment. V equals AT. Negative 13 is the velocity. So where it says velocity, I'm going to put in negative 13, straight from my list. A is negative 10 time. To get the time by itself, and now this is important because I saw a lot of people do the wrong thing here. What this is really saying is this is negative 10 times t. The opposite of times is divide. So what you're going to do is you're going to divide both sides by negative 10. Negative 13 divided by negative 10 is 1.3 seconds. Equals the time. So when you're solving for t, you divide by gravity. That's it. Every single time. Every single time. All right, let's see that again. So how long? Means we're looking for time. Time equals question mark. End up moving. Negative 78. We always know that our gravity is negative 10, but it's negative 78. Because it's meters per second, I know it's a velocity. Okay, same deal. V equals AT. Negative 78 equals negative 10 t. Divide both sides by gravity. gone. 7.8 equals the time. Seconds, of course. That's it. That's how this works. Let's see it again. How long? T equals question mark. A equals -10, and then the velocity is going to be -120. V equals AT. V equals, the velocity is -120. Don't forget to do that. You can, I clearly just did. I was moving quickly, and I forgot that I am not just going to multiply these. I'm going to sub them in, and then I'm going to divide both sides by -10. When you're solving for the time with velocity, you have to divide by -10. 12 seconds is the time. All right. So here are the first three that you had on the sheet. Watch this. Watch this. Looking for time. We have velocities. It's dropped planet Earth. So we're looking for time. We know A is -10. And we know that these are velocities because of this meters per second. That's how we know. That's how we know, because of the meters per second. So we're going to have V equals AT. -209 equals -10 t. Divide both sides by -10. 20.9 seconds is the time. Lastly, I'm just going to write this one out. That's my division sign, by the way. Don't get confused by that. That is all you have to do on this, folks. Now, a ball is dropped on planet Earth. How long? Okay. How long? Because it says how long, all these questions, I said you have two equations you can pick from. V equals AT, or D equals 1/2 AT squared. So we just did a bunch of problems with the velocities because they had meters per seconds. But if I read this problem carefully, all right, let me make my little list of variables. This is how long is time, so T equals question mark. We know A is -10. To end up traveling down 105 meters. When I see meters, I know that's a distance. Meters is a distance. You have to know that. So if you see this in your brain, little lights need to go flashing off. That's a distance. And because it said down, I know it's negative. Even though I didn't write negative, the word down means negative. So because I have a distance in all of these problems. I have a distance in all of these problems. So because I have a distance, I have to use the distance equation. I can't use the velocity equation here because I don't have a velocity. That's how you figure it out. If you have a velocity, you use the velocity equation. If you have a distance, you use the distance equation. And that's how you figure out which equation to use for when it says how long. Now, the math for this was a bit hard. There were 3 steps. D equals 1/2 AT squared. The first thing I'm going to do is simply plug the numbers in. The distance is negative 105. 1/2 negative 10 t squared. Okay. I gave you 3 steps for how to solve this. The first step, step 1, take half the gravity. So what you're going to do is you're going to look at the gravity and you're going to take half of it. That's step 1 right there. Step 1, take half of the gravity. Okay. What do I do with the other stuff? Just bring it down. You're not going to do anything with it yet. Okay, so negative 105, half of gravity, well, that's half of negative 10. That's negative 5 t squared. Okay, nice. The second step is to divide both sides by half of gravity. So, okay, hold on. Just like before, when I divide, how's this going to work? So now this is the step 1. Step 2 is going to happen right here. I'm running out of room. That's okay. I am going to divide both sides by half of gravity. Negative 5 and negative 5. Okay, awesome. This cancels out, and what I'm left with is a negative divided by a negative is a positive. Okay, 21 equals t squared. This should almost always be a positive number, because when you do the third step, which is square root, and I apologize for running out of space, square root both sides. What does that look like? What does square rooting both sides look like? So now we're doing step 3, okay? Square root, square root. The square root of 21, and make sure you know how to type this in your calculator, is 4.58. Give me 2 decimal places. That's a good thing to do. All right. So this is the answer for how long it takes to travel down 105 meters. You use the distance equation, and then you use these 3 steps. 1, 2, 3. Half the gravity. Divide both sides by half the gravity, and then square root. Let's try it again. Let's try it again. When I look at question 2, okay? When I look at question 2, let's just see if we feel comfortable with this process, okay? So make sure you write down the answer to number 1. The only difference between question 1 and question 2, because question 2 still says how long, all right? So still looking for time. Still looking for time. No, it's dropped, so the A is still going to be negative 10. The distance is different. Instead of negative 105, because it's down, it's going to be negative 198. So I'm going to put negative 198 right here. But the 3 steps still work. I'm still going to take half of gravity. That's still going to be my first step. I'm still going to divide both sides by half of gravity. Half of gravity was negative 5, so I'm going to divide both sides by negative 5. That's going to cancel that out. So I'm at negative 198 divided by negative 5, and I get 39.6 equals t squared. And I got to square root that junk. And when I square root that, it's going to be 6.29 seconds equals the time. That's it. The third question is the same thing, but with a different distance. So let's see how that works out. Don't forget to pause and rewind if you need to. I didn't mean to erase that. Whoops, that's okay. That's okay. That's okay. Down, negative 270. Net, because it's down, it's going to be negative 270. Half of negative 10 is still negative 5. See, I wanted to leave that there to show you that that was always going to be the same every time. But that's okay. That's okay. Negative 270 divided by negative 5 is 54. Oh, let me show you that. I jumped ahead. Let me actually write it out. Step 2, divide both sides by negative 5. Half of gravity. And that's how I get positive 54. Don't forget, a negative divided by a negative is a positive. You should always have a positive number when you get to t squared. Now I got to square root that. And I should get 7.345 if you round. If you round, don't worry about it. That's it. That's it. I apologize for putting these out of order, but these are the first 2 questions on the section. We're still going to use the same equation in the same 3-step process. Let's take a look at how that would be right here. Because I'm saying down 14, I'm going to have a distance of negative 14. Because I'm dropped on planet Earth, my A is still going to be negative 10, and the T is going to be squared. My first step is to take half of gravity. Half of negative 10 is negative 5. If I divide both sides by negative 5, divide by half of gravity, I get 2.8 equals t squared. And then if I square root that, I get 1.67 seconds is the time. The exact same process is going to happen down here. Negative 49 equals 1/2 negative 10 t squared. We plug the distance and the acceleration from gravity into the equation, into this equation. Then I take half of gravity. And I divide both sides by half of gravity. That's step 2. And I'm out of space, so I'm at 9.8 equals t squared. And then I got to square root that junk. Go ahead and check your work. See if you could follow this math. Don't be afraid to ask for questions on this or watch it a couple of times because I know it's tricky. So, this is where it gets a little tricky. But we're going to take what we just learned in all the previous slides and apply it right here. Because it says, imagine you travel to another planet that has a gravity of negative 15 meters per second squared. So now, A is not going to be negative 10. Because I'm telling you a new gravity, A is going to be that new gravity, which is negative 15 meters per second squared. But everything else is still true. What do you mean by that? Because when I say how fast, we're still going to use V equals AT. When I say how far, we're still going to use D equals 1/2 AT squared. And when I say how long, it's going to be one or the other. Okay, let's see how this is going to work. How fast would it be going at 4.3 seconds? V is question mark. A, in this case, is going to be negative 15 meters per second squared. T is 4.3 seconds. That's it. V equals AT. V equals negative 15 times 4.3. And I just simply multiply it. V equals negative 64.3 meters per second. That's it. How far did it go after 4.3 seconds? Well, let's take a look. When it says how far, we're absolutely going to use the equation d equals 1/2 AT squared. We know that we're looking for distance. We know that the gravity, in this case, is now negative 15 because we're on a new planet. And we're going to use the time of 4.3 seconds. Oh, it's squared. Thank you. That's it. You just are going to plug in the negative 15 for the A's, just like you were doing negative 10s. It's the exact same process. That is all that we are doing here. D equals negative 138.675 meters. Done. So that's how you can do it with a different gravity. But how am I supposed to do it? How am I supposed to do it when it says how long? So now these questions aren't in order. I have to just read them and figure them out. Okay. Let's read it. Let's see if we can figure out which equation to use. When it says how long, that means I'm looking for time. So this one says how long, so I'm looking for time. Time is question mark. All right, we're on this other planet where A is negative 15. So I know A is going to be negative 15 because we're not on Earth anymore. And then it says negative 50 m/s. Oh, I know that m/s is a velocity. So because I have a velocity, I have a choice of using the velocity equation or the distance equation. I'm going to use the velocity equation because I have a velocity. So I'm going to use V equals AT, and just like before, negative 50 equals negative 15 t. And then I'm going to divide both sides by negative 15. And when I do negative 50 divided by negative 15, I get 3.33 seconds is the time. And then when I look at this last question, it says how long. So how long is time? Okay, we know we're on another planet, so we're still going to have this negative 15. All these questions have this negative 15. So like if you see this overhead, this heading here, right? This is going to apply to all the questions that go beyond it. All right, so you're still on this other planet. And then it says traveling down negative 80 meters. Okay, so I gave you the negative that time. It was nice. And I know that meters is distance. Because I have a distance, I'm going to use the distance equation. Because I have a distance, I'm going to use the distance equation. And I'm going to follow the steps. Negative 80 equals 1/2 negative 15 t squared. But let's really watch these steps here because they're going to be different. Well, no, the steps are the same. The numbers are going to be different because this time half of 15 is going to be negative 7.5. All right? But the first step is to always take half of gravity. Everything else comes down. Then I divide both sides by half of gravity. Negative 80 divided by negative 7.5 is 10.66 equals t squared. And the last step is to square root. The square root of 10.66 is about 3.26. So the three steps are still the same, even though there's a different gravity. The process doesn't change. And that's it. This goes over every main concept skill that we've learned about gravity so far. And this is what you are going to be responsible for knowing for our quiz coming up.